If a successful rocket launch is like a beautiful dance performance, then the launch tower is the stage on which the performance takes place. For the dance to be perfect and safe, we need a sturdy stage, and SpaceX has excelled at providing just that. They have developed large launch towers, continuously improved their performance over time, and it's even cost-effective. This completely humiliated NASA and its mobile launch tower. And why is that? What problems is NASA facing with its own tower? Let's go over all the details on today's episode of Alpha Tech. SpaceX envisions an ambitious spacecraft designed to navigate through space, transporting both humans and diverse payloads. This represents the most monumental space exploration initiative to date. Therefore, it's evident that a single launch tower for Starship won't be sufficient to meet the operational frequency that the company wants. As of 2023, SpaceX operates 4 launch facilities. One at Cape Canaveral Space Launch Complex 40, Vandenberg Space Force Base Space Launch Complex 4E, Kennedy Space Center Launch Complex 39A, and the Brownsville Launch Site in South Texas. If SpaceX were to construct one launch tower for each launch facility, including the 2 towers planned for Boca Chica, the total would be 5 launch towers. This calculation doesn't even account for the offshore launch tower that Elon Musk recently hinted at during the International Astronautical Congress in Baku, Azerbaijan, which took place this year. At that time, Elon Musk said, "But we may end up doing platform-based launches from a specially designed sort of ocean-going platform." This is a figure that can be considered the highest among the rocket companies currently conducting launch operations. Just on this aspect alone, SpaceX has surpassed NASA in the scale of launch towers for the future. Additionally, SpaceX is capable of constructing the Mechazilla within a relatively short time frame, which is around 6 months at the Starbase facility, and potentially even having this time when building a launch tower in Florida. Meanwhile, a tower constructed by NASA takes about 2 years to build initially and essentially 8 years for modifications. In terms of cost, SpaceX's metal launch tower segment is relatively affordable. Standing over 145 meters tall and equipped with robotic arms and the power to operate them, each tower costs approximately $100 million US. In contrast, NASA's launch towers are considerably more expensive. NASA's mobile launcher, for instance, comes with a hefty price tag of up to $1 billion US. It's also the launch tower used by NASA for the Space Launch System, which not only faced significant delays and cost overruns, but is also considered a single-use structure, which means it'll be discarded after the initial rocket launch. Thanks to SpaceX's cost-efficient development approach, without compromising quality, the expenditure for a Starship launch is around $2 million per mission. While this may sound substantial, it's a small fraction compared to the current average launch cost for NASA, which stands at $152 million per launch. In essence, if Elon Musk's vision holds true, SpaceX could potentially achieve space missions for cargo and humans at just 1.3% of the cost NASA currently incurs for similar missions. NASA is now working on a second mobile launcher to accommodate the larger Block 1B version of the SLS rocket. Bechtel won this contract to design and build the second, larger mobile launcher for $383 million by March of 2023. This would be about 1/3 the cost of the first mobile launcher in half the time. Past performance would suggest this is unlikely. Not only does the cost of the Mechazilla tower from SpaceX leave NASA astounded, but another unique aspect truly sets SpaceX's launch tower apart from all others. We're probably quite familiar with the claws of launch platforms when they connect with rockets. Typically, rockets that are supported by strong backs are rockets that are delivered to the launch pad in a horizontal orientation, because it's easier to build and house a rocket horizontally in a building than vertically and then need to be tilted up to a vertical orientation. The strong back keeps the rocket from bending in half while this occurs, and usually features a claw like the one seen here. In this photo is is a Rocket Lab Electron rocket with its strong backs retracted just before launch with its claws very visible. In contrast, rockets without strong backs are typically assembled vertically and then rolled out to the launch pad in a vertical position. These rockets require less support, and while connectors provide some stability, the rocket is not as reliant on them. For instance, the Saturn V shown here did not have claws as part of its tower connectors. However, SpaceX's launch towers boast a distinctive design. The claw for SpaceX is referred to as the quick disconnect, or the ground support equipment stabilizing arm shown here and attached to the launch tower. It addresses factors that contribute to the benefits of the Starship launch process. It can provide propellants, power, etc. to the Starship second stage of the Starship vehicle itself. It can also stabilize the top of Super Heavy, both when the Starship vehicle is stacked and before. That last part is key to the arm's design. While practically every other rocket is stacked in a hangar and then moved to the launch pad in its final form, Starship and Super Heavy are designed to be stacked at the launch tower. When Starship is being stacked onto Super Heavy, they need to line up at least 3 connectors on the booster with slots in the rear of the Starship. The chopsticks catching arms will have a fairly rigid hold of the second stage connected to the chopsticks with 4 rigid mounting points. Meanwhile, Super Heavy would only be supported at its base. But if strong winds occur, the top of the Super Heavy could sway along with it, making stacking impossible until said wind dies down. SpaceX has previously stacked Starship onto Super Heavy using a crane without relying on GSE arms for stabilization. However, what SpaceX wants is to be able to stack and launch Starships in any possible weather conditions. That's why the Starship launch tower requires the GSE arm. With the GSE arm, they can securely grip the top of Super Heavy, keeping it steady while the catching arms stack Starship. Another distinguishing feature is that compared to other launch tower connectors like Saturn V, which had multiple connectors for each tank due to its multiple stages, this was necessary as each stage required its own set of connectors. On the other hand, the Super Heavy rocket has a unique setup. Its single GSE arm braces the very top of the rocket, or the first stage. Simultaneously, it employs a GSE quick disconnect system on its top to supply fluids and power to the Starship, the second stage. So, unlike the Saturn V, which had numerous connectors for each tank, the Super Heavy relies on a single arm for the first stage and a quick disconnect system for the second. Another unique element about the GSE arm is that it's attached to the rear of the tower and reaches all the way around connecting to Starship and Super Heavy. Unlike other launch towers where arms are positioned on the side facing the rocket, the GSE arm is attached to the rear, extending all the way around to connect with Starship. This peculiar configuration is necessary because the arm needs to clear the path for the giant catching arms carriage. In contrast to conventional towers, the GSE arm is positioned to avoid interference with the catching arms carriage, which can move up and down the tower along rails on 3/4 of the corners. This clearance allows the catching arms to descend close to the launch pad, facilitating tasks like lifting a Starship off a transport or providing easier access for maintenance. The flexibility of the catching arm is crucial. They can travel down to just above the pad for tasks like lifting a Starship or ascending to the top to meet a descending Super Heavy. The arms move down the tower to stay alongside the booster, ensuring a smooth and controlled capture in case everything goes according to plan. Currently, SpaceX has successfully constructed 2 Mechazilla towers, one at Starbase and another in Florida. The number of towers is expected to increase significantly in the future as Starship achieves orbit, and to be honest, long-term launches are set to take place in Florida as an alternative to the developmental and testing site of the rocket in Boca Chica, which has been subject to prolonged regulatory scrutiny from government environmental agencies. However, NASA officials have conveyed to SpaceX that a Starship explosion at Launch Complex 39A could effectively sever the sole means of launching American astronauts to the International Space Station. Therefore, SpaceX has expedited the construction of an additional backup launch tower for Crew Dragon missions to alleviate concerns expressed by NASA officials. The Crew launch tower is gradually nearing completion, promising a perfect setup for launching the colossal Starship spacecraft from Florida. Well, that's about it for today's episode. We hope you enjoyed it and learned something new. Please let us know your thoughts in the comment section down below because your feedback is very important to us and helps us make better videos. And so for that, we thank you so much again, and we hope to see you again next time.